Hi, so my name is Vivian Lee, and I'm a developer on the application services team at InterSystems.
I'm Dominic Chui, and I'm also a developer on the app services team here at InterSystems. So app services is a development team, and we're in charge of about 12.5 internal applications used across the company. And these are all built on our own Iris database platform.
All right, cool. So thanks for taking the time to join us today. Today we will be presenting on updating legacy UIs for modern browsers, and we'll be sharing lessons we learned from our team's own experience doing this update with one of our homegrown apps. And we hope that you might be able to take away some helpful takeaways for your own use cases. Cool. So our plan for this presentation is to first introduce the background and the motivation for this update, to explain a little bit about the app that we've been updating and why this update was so important and necessary. Then we'll share our recommended high-level approach for anyone who's looking to do a similar update for their own legacy app, before going into specific examples of cross-browser tips and tricks that we learned along the way. And lastly, we'll end with an example of how we utilized InterSystems ISE REST package to show different navigation menus based on which browser the user was using to interact with the app.
Right, so why are we here to talk about this? The answer is that we've had a major project to move one of our own applications from something that relied on Internet Explorer to something that could be used in modern browsers. We've run into various interesting challenges along the way, and we thought it would be helpful for all of you to kind of learn about them as well. So this application is our homegrown customer operations and finance application. So it does invoicing, billing, reporting, license key generation, and all that kind of stuff. It was built and released back in late 2001, which was quite a long time ago. You know, predates me. I've been here in InterSystems for about 3 years. So back then, everything kind of relied on Internet Explorer. Right, everything was built on the back of Microsoft then. So the application is kind of a mix of different styles, right, as it's evolved throughout the years. About half it is built on this kind of XML, XSL kind of style, and half is on our CSP style. None of it, notably, is on any sort of our modern, Angular frameworks or any of that. It's all just built on HTML, CSS, JavaScript, this kind of thing. So it is fairly large and complex. Last we counted, there are about 115 pages. Some of them are probably barely used, but still exist. So for the XML pages, we have something that it can kind of rely on something known as XSLT. XSLT is a language used to convert XML into other XML or into other formats like HTML. And that's kind of how we get web pages to generate, right? We take our XML data, run it through XSLT, and we get XHTML, so we can display as pages. One fun thing about how it used to work is that it ran on an old version of XSL. So the XSL 1.0 standard was released in 1999, but this application was built on the WD XSL standard, which was a prototype Microsoft standard built even before then. If you try Googling WD-XSL, you get very few results. There's very little documentation on how it works, what are the differences and all that. And we had to get a contractor to kind of help us migrate to modern XSLT. The question, of course, is, what are the main drivers for us to move towards modern browsers? And there are kind of three of them. The first and foremost, and most important, is that Internet Explorer is dead. Long live Microsoft Edge. Right? The only way to access Internet Explorer nowadays is through Internet Explorer mode in Microsoft Edge. We don't know how long Microsoft will keep that around for, so it's best if we move along off the platform. The other problem is that we have quite a few users who run on Macs, right? They like their sleek Macs and their ability to, do all this cool stuff on their Macs. In order to access Internet Explorer through a Mac, you have to run a Windows VM, right? Which that provides, is a kind of a pain point for users, right? They have to log onto their Mac, they need to log onto a Windows VM, log onto the website, run whatever report they need, then move the report from their VM out of the VM, right? So when talking about like salespeople or account executives or like bigwigs, right? They don't really want to have deal with the extra hassle to do all these extra steps just to get a report out of the system. And kind of the third, but probably the least important, is that Internet Explorer is just not that great to work with from a development point perspective, right? The development tools are just kind of lacking compared to something you get on Chrome, for example. This is why we've had kind of a long-running process to move from IE to something like Chrome, right? The process has picked up a little steam recently as Microsoft has officially retired IE. But this has not been a process that started a year ago, right? It's been like multiple years. One problem with the application, or the process rather, is that we can't just stop all business work and try to move it over immediately, right? There's been a lot of various business requirements that have come up in these years that we need to manage and adapt to, right? There are new requirements coming in for how we want to handle the application and what its features are. And that way we have parallel tracks for work, right? One track is keeping up with the business demands on the application, adding new features, making sure our users are happy with it. And the other track is moving to modern browsers. So this is kind of the general approach for how we tackled it. First, we wanted to reskin the app. Modern day apps kind of want a modern day feel and look to it, and that's why we do some CSS to change how the whole application looks in the new UI. And it's much easier to do it through CSS than trying to modify each individual page for obvious reasons. In terms of the big picture approach for how we did it, we had the idea of we want to make it a list of prioritizing different pages for work. And there's multiple ways we can go about it, right? We can go alphabetically. We can start with the About Us page that no one ever reads, and end with the Zebra page that is secret and hidden and no one knows about. Or we could do it randomly. We draw page notes out of a hat. We can ask ChatGPT what it thinks. Unfortunately, we started this before ChatGPT was released, so that was not an option. But if you remember, one of the key things about our move was that we want to kind of support people like salespeople who run just one report. And it turns out these reports are kind of similar in their structure. And since these people rely on only this report, or a handful of reports, if we moved these reports to the new UI first, we can get some subset of our users off our old UI. And that's kind of the approach we took initially, right? We find the list of most used reports and then move them to the new UI. After that is done, we then moved on to kind of big picture pages, the most important ones that are most critical. After those, we can move to the less and less important pages. What's key throughout this process is that we looped in our key stakeholders in every step, right? We wanted to make sure they were on board with what we're doing and they were aware of what we'd prioritized and they're happy with it. On a page-to-page basis, it's a pretty simple process, big picture-wise, right? We look at the page in the old UI in IE, figure out how it works. Look at the new page in Chrome, for example, see how it doesn't work. Does it look off? Is the alignment wrong? Did the buttons not work? Did the buttons show up at all? And then we kind of go fixing things, right? We fix everything of that, put it through the various environments, and finally we release the page in the new UI so that users can use it. One interesting question was, how do we actually show page users the pages in the new UI, but not show them anything that's broken, right? So one option, of course, is to have a kind of a roles-based approach. We already have roles-based approaches in seeing for how what pages users can see. But one downside of this is, let's say we give all developers the ability to see all the pages. Then it's somewhat trickier for them to figure out, okay, what can a person with this kind of role see, right? What has actually been released? You need to go digging for those. Instead, what we did was kind of have a default mode and a beta mode. And in the default mode, you can see only the pages that have been released and are shown. In the beta mode, you can see all the pages. That way, a developer can see both all the pages, figure out what's broken and what's not, and also see what users can actually see.
Right. So throughout this project, we learned that it can often be more challenging to change a piece of code so that it's compatible in all browsers, like Internet Explorer, Chrome, Edge, Firefox. And sometimes the quicker and easier solution is to modify what is done or displayed based on which browser that the user is using. So for example, we quickly realized that there were a lot of cross-browser challenges with our original main page for our app, and that it would honestly just be a lot more difficult and arduous to get it to work in all browsers rather than just create a new cross-browser compatible shell. So that's what we ended up doing, so that if the user was using the app in Internet Explorer, they would see like the homepage that they were familiar with. But if they tried to launch it in a more modern browser like Chrome or Edge, we'd show them a new, like reskinned, modern-looking homepage. So other things that we did were we automated updates wherever we could. Like Dominic previously mentioned, some things that changed were like XSLTs and like the versions from WD-XSL to 1.0. That's something that was mentioned, like that was hard-coded in hundreds of templates files. So that's something that you could automate so that you don't have to do manually, like with a bash script. And then you can use like handy tools like grep just to make sure that there are no occurrences of those old references. And then we also provided polyfills and shims as much as possible so that we can keep existing JavaScript patterns that were introduced when the app was first written working in modern browsers. So just for a quick overview of what polyfills and shims are, a polyfill is a piece of code that implements a feature that a web browser does not natively support. And this can be things like objects or classes that might exist out of the box in some browsers, but that aren't defined in other browsers. So in these browsers, when the reference to that like piece of code is hit, the browsers where it's not natively supported will see this reference, have no idea what it is, and it will just either, worst case, it'll freeze and your page won't load, or the app will appear to have crashed. Or it will load and visually look okay, but like won't actually do what you want it to do. And neither of those are a good solution because we want to keep the app working for our users. So then a shim is a library that intercepts API calls and it handles the operation, or it passes it to another known library for it to handle. So essentially, a polyfill is a shim for a browser API. And in our project, one area where we used polyfills heavily was with our XML handling. So our application relies on performing a lot of XSLT transformations to present data and to take data and present it in a very specific layout format. But the ActiveX object that we were relying on that exists natively in Internet Explorer doesn't exist in modern browsers. So to handle this, we created a custom XML document polyfill to replace the ActiveX object so that the developer can interact with it the same way they would interact with ActiveX object and basically get it to mimic the same features. So now we'll be going into the technical segment of our presentation and diving into the weeds on tips and tricks we learned. And these will be more browser-specific details and differences rather than about Iris. So we'll be going into, we'll be highlighting some CSS styling rules and method differences, some JavaScript syntax differences, XML XPath differences, and elements, methods, and objects that are supported out of the box between the browsers or shared between all browsers. And then lastly, we'll be showing a unique bug that we discovered with Zen report attachment handling, where the behavior differs between browsers. So get ready, this is gonna get very specific. So first, with CSS styling differences, one thing that we noticed early on is that Internet Explorer supports this call table element, which can be used to apply styling rules to all cells in a specific column in a table. And this approach to styling table columns was used very heavily throughout our legacy UI. But unfortunately, this element isn't supported in modern browsers, which at the end of the day meant that none of our browsers, when rendered in a modern, none of our tables, when rendered in a modern browser, had any of the styling rules applied. So our workaround was to try to minimize the number of HTML changes that we would need to make. And instead, rather than changing the HTML, we could try to keep those call styling elements and manually apply those rules if the table was rendered in a new browser. That way, it would continue to work in the old app, and the new, in new browsers, those tables would be styled. So, okay, so our approach to do this is, or one approach that you might take to do this that we used was, first we added a unique ID to the table element. Then we checked if the user was rendering that page with the table in a non-IE browser. And then we used JavaScript or jQuery to grab all the table elements inside the table, which we would locate by the table ID that we defined, and then parse the CSS rules from each call element and add it to a new style element where each rule is applied to each respective column. Cool. Okay, so to do this, while modern browsers don't support the call table element, they do support a CSS pseudo-class rule that is called nth child. And this is functionally very similar to what the call table element does, in that it can apply styling to individual table columns. So to see what this looks like in code, we're just going to go through this abstracted example. And yeah, you see here that we start off with a new text string that we're going to call CSS. And we have all the call elements in this array, and we iterate through each of them. And for each call style element, even if a column doesn't have specific styling rules applied, it still has to exist just so that we keep the index order for the table visually there. And we first check if the call has a style attribute, in which case that means that that column has specific style rules applied to it. And if it doesn't, we exit and move on to the next column. But if it does, we grab the style attribute rules that are defined, and we apply it to each table header and table cell in that column. And then also, just to note, the nth child CSS pseudo class is one indexed. So we had to add one for each column. Yeah, cool. Then we created a new style element, defined that this type is, these are CSS rules that we're adding, and we appended that style element to the document, and then lastly, appended that style element to the table, which meant that when rendered in Chrome, all of those tables would be properly styled. Okay, so another styling difference that we noted between browsers is that Internet Explorer sets the box sizing rule for every DOM element to border box by default. And just for a quick overview of what the border box rule is, so the border box rule means that for if you, sorry, I'm just gonna open this. Okay, right. So if you look on the right, for an element, in which case you define that the width had to be specifically 100. If there's any border or padding to that element, like a border padding of 5 and then also a padding rule of 5, that the actual content would auto adjust to 80, so that the entire element would fit within that width rule that you specified. But in modern browsers, the default is content box, in which case the actual content would not auto adjust. It would stay to whatever you specified as 100, and it wouldn't include the border or padding, so that the total size is 120. This is a really small difference, but it could actually really make your UI look kind of weird. So in order to get the pages to appear identically in Internet Explorer and modern browsers, we had to manually set the box sizing rule for all the DOM elements. And this is just a snippet of a CSS example of how we did that, by grabbing every element, and then also, I guess just to be safe, we also grabbed the body, div, and table cell elements and specified the role there. One thing to also just note is that border box is currently not supported in Firefox, which we touched a little upon later when going over which browsers can be supported for this cross-browser project. Another difference that we noted in Internet Explorer and modern browsers is just the need to specify the width of DOM elements very specifically. In modern browsers, we just also had to specify a min and max in addition to the normal width, all with the same values for that width to be respected, whereas we could be a little more lax and just specify width in Internet Explorer. And also, Internet Explorer does this sometimes helpful thing where child elements in a table for table cells will inherit styling rules like padding from their parent elements. And modern browsers give you more flexibility and don't make this assumption. So if you want it to inherit styling rules, you need to explicitly tell it to. Okay. So lastly, just a couple like CSS tricks that we learned that we found useful that we wanted to pass along were the important flag. So adding the important flag to the end of a CSS rule is like the equivalent of playing a trump card. So if you have other styling rules defined in an external CSS style sheet that you're importing, or inline styling rules, any rule that has this important flag will trump all those rules. In this example, this means that all table cells will have their font color be red, regardless of other styling rules that you might have applied to table cells in other ways. Another thing that we found useful was the star equals attribute selector. And this applies a rule to all elements that have an attribute whose value contains a specific string that you're searching for. We found this really useful because we actually had a typo in hundreds of files, and which we highlight here, that there was just one extra space put between this padding rule between like the unit and the number. And because of this typo, when rendered in a modern browser, like this styling rule wouldn't get applied. So this is an example of where we found this like star equal selector very useful, so that we wouldn't have to go back and change all these files for the typo.
Next, I'll talk about some of the syntax differences. These are mostly going to be small little things that differ between the browsers. We're going to start with JavaScript's declarations. So anyone who works with JavaScript knows that there are 3 ways of declaring variables, right? You can do the classic var, or you can use let and const. The problem with let and const was that they were released, I believe, in 2015, and are not supported in Internet Explorer, or at least the version we're using, which means they are not usable for our application, right? Because our application is still halfway in this project, right? We have not completely moved over. Any development work must avoid let and const, despite all the kind of advantages you get from the ability, for immutable const, or the better scoping of let. And that's just something to keep in mind. Another one, this is a little one, but in most modern programming languages, we're used to accessing lists in square brackets. Internet Explorer allows you to access them using parentheses, right? If you have some list and you want to access the first element, you can use the rounded parentheses to do so. It does not work anywhere else, and it will just fail in Chrome. So in all browsers, in all other browsers, you must use the square brackets. Luckily, this also works in Internet Explorer, so you can just convert all your calls to using the square brackets. Another one's about attributes. So we have our standard HTML attributes. For example, all HTML elements have an ID, all anchor elements have an href, all image elements have a source. And these are accessible through kind of a dot syntax, right? We have an element, dot, the attribute name. We also have methods get and set attribute. These allow you to get and set it. We have non-standard attributes that you can define yourself, right? And these can be used to kind of store metadata or whatever other data you feel is necessary, right? Examples are name, currency, or year, if you want to put into a field of some sort. And this is accessible in dot syntax only in Internet Explorer. And this will be a theme throughout. Internet Explorer very much likes the dot syntax and will allow you to access a lot of things through the dot syntax, but no other browser does. In other browsers, you have to use the get attribute and set attribute. In a related thing, disabling elements is kind of a handy feature, right? Let's say you have a checkbox and you want, in some situations, to not let users click it. In Internet Explorer, you can just set the element.disabled equals true, and then to unset it, to re-enable it, you can just do element.disabled equals false. It does not work in Chrome. Instead, you must use the set attribute and remove attribute methods. To disable it, you call set attribute disabled true. To disable it, unfortunately, you cannot do set attribute disabled false. It'll remain disabled. what you have to do is call remove attribute. Let's think about XML. In Internet Explorer, you're allowed just empty XML. It's perfectly happy with it, no problems. It will not behave well in something like Chrome or Edge, right? It wants one of three things in all elements, right? A child element of some sort, inner text, or a non-breaking space. Next, we'll talk about kind of XPath scopes. So XPath is a way of kind of traversing your XML nodes. And this is actually kind of an interesting scoping thing, where Internet Explorer is, as perhaps expected, more permissive about what it allows you to do. So our example here is we have some kind of XML data, we have a root, and inside we have a table element. Note that this table element is not an actual table, it is an element called table. And it is used in this specific instance to say that the user has checked the show table option. We also have a group of our items. So in our XSL, we have a template, right? We're trying to match the group, and we're trying to figure out, has the user selected the table option? And in the XSL when if, so this is kind of like an if statement sort of thing. It says, we're looking at the group, and we're trying to go to the same level. Right? We're looking at the kind of a sibling of the group element to the table element. If it is present, we do stuff for each item. Unfortunately, this is only accessible in Internet Explorer. In Chrome and Edge and all the others, you're not allowed to access anything that's not the elements, the node, or its descendants, right? And because table in this situation is a sibling, it doesn't have access to it. Instead, you must kind of do something more like this, right? We have developed an attribute called table format, perhaps a little better name, so you now know it's a format and not just a table pretending to be something else, or sorry, something else pretending to be a table. And your XML would then be, does the group element node have this attribute? Next, we'll talk about some of the method and object differences. This is just kind of a big table that shows you a bunch of methods you can use to select DOM elements, right? There are a whole bunch of different methods. They all kind of do something a little different. Some of them return all matches, some of them return the first match. You know, they're all kind of called differently. But what's important to note is that some of them work in IE, and some of them don't. Some of them work in Chrome and don't work in IE. As such, because we haven't finished moving from IE completely, we cannot use anything that is not available in IE to maintain backward compatibility. You'll note that we have some stars here, and that's to show you that in specific cases, we have built in polyfills so that we can just rely on the functions. And one handy way of kind of utilizing this is that we have methods to determine, is the user in IE or are they on some other browser? If they're in IE, we just call the original some methods that are maybe faster. If they're not, we can call other methods that are faster for that.
Right, so if you remember an approach that we discussed earlier, it was about modifying what's executed or displayed to the user based on which browser they're using to access the app. And here we just show you an example of a code example of how we do that with a custom function to check whether the user is in Internet Explorer or a different browser. This function checks the user agent and searches for specific strings that should appear if this is being executed in Internet Explorer. Then it returns a version number if it was executed in Internet Explorer, or false if it was executed in another browser. And it's something that we found very helpful during this project.
This is another little thing. Once again, Internet Explorer loves the dot syntax. You can access child elements by ID through the dot syntax. Chrome and Edge do not like it, and you have to define something more akin to like this method, for example, which is a recursive method. You give it the node, you give it the ID, and it just recurses down until it finds the child node you're looking for.
And then here we list different array methods that are available in modern browsers only, and methods that are available in all browsers. So newer JavaScript programmers might be familiar with methods like for each, map, and filter. These functions let you iterate through each element in an array, or apply some function to every element in an array, or filter an array and only return elements that match like a specific condition. Unfortunately, these aren't natively supported in Internet Explorer, so for developers who are looking to do a similar update of their legacy UIs while also adding new features that they want to be available in both Internet Explorer and the modern browser, we just recommend going with the classic for in and for of loops, and these are available and work as expected in all browsers.
So one kind of fun thing about Internet Explorer is that it allows you to do a lot more than you perhaps should be able to do. And one of these is write files to local machines. This is a bit of a security risk, and that's why it's not available in modern browsers. But one thing that the app does do is it uses ActiveX objects to write files. Let's say a user runs a report, and they want to save it to the machine. Well, luckily for you, the Internet Explorer version just does it for you. It's automatically downloaded to your machine using this kind of ActiveX objects code. But because modern browsers are a lot more security aware, and that perhaps letting browsers and websites download files to your system is perhaps not the safest thing to do, this is not allowed. So instead, what you should do is kind of use a blob, which is a bit of kind of like a mutable data. And right, you see we create a blob here and just append all the data. And that way we can open up the report and give the user the option of whether or not they want to save the file without forcing it upon them. So here is kind of a really interesting case that we ran into a few months ago. So we have one of the reports it's built in Zen Reports, which is a way built into InterSystems Iris for generating reports. It will be discontinued, I believe, so it's not going to be here forever. We have a report that's runnable in both an HTML version and has an Excel mode output option. What was interesting about this one was that the HTML output worked in both browsers, IE and Chrome, no problem. But in the Excel mode, it didn't work in Chrome. What we got was this fun message that says, Excel cannot open the file because the file format or the file extension is not valid, blah, blah, blah. And that's kind of strange. We tried it across different environments, tried Chrome, Edge, Firefox, and we all kind of got the same results. So what we did was we opened the file up and kind of look at it, see what's inside. So on the left is Internet Explorer, on the right is Chrome. Obviously, the file is not going to be very human readable, but we're just kind of curious about what does it contain. You'll notice it starts with PK, which is what we expect, because we know Excel files are just zip files that are a little fancy, and zip files start with PK. There's a whole bunch of control characters, and that's expected. Chrome has a bunch of extra spaces, but that's not necessarily in and of itself a problem, or it doesn't tell us what's happening. But if we open it using the less command from the Unix terminal, we kind of get this, right? We'll notice that there's a lot of Unicode on the Chrome version. And that kind of told us what was happening, right? This was an encoding issue where somehow Chrome was interpreting all the data as Unicode encoded instead of just being a binary stream. So we had to write a method in our reports, present on pre-HTTP, and just tells it to treat it like binary text, stop trying to convert it to UTF-8. And that's just resolved the problem. And this is kind of a little snippet of code that just works and helps prevent it from kind of breaking in Chrome.
Right, so another example that we want to highlight isn't a cross-browser bug fix, but actually rather more of a cross-browser performance enhancement. So we had a form on one of our app pages that we noticed rendered extremely slowly in Chrome. Anytime that a drop-down field value is changed, the form would just kind of appear to freeze and then lag for a very long time before it became editable again. And we found that ultimately the root cause of this issue was that we were making a lot of calls to this select nodes function anytime a drop-down value was changed. And if you recall, select nodes it was not a method that was natively supported in modern browsers that we had to create like our own custom implementation for with a polyfill. And even with our best efforts to optimize this custom implementation, it was still a lot slower than what was natively supported out of the box in Internet Explorer. So since we already did our best to optimize this function, our solution was to try to minimize the number of calls that we make to this function. we noted that the data that we were using to determine like what drop-down values would be shown in other drop-downs when the first drop-down was changed, that data wouldn't change until the form was submitted. So we were able to utilize a hash map to store the data, and as you guys know with hash maps, we were able to perform very quick instant lookups. And this significantly improved the speed of like the form in Chrome, and is great because hash maps are natively supported in all browsers. So we were also able to see a slight performance enhancement as well with Internet Explorer. Lastly, we wanted to showcase an example of how we used the InterSystems ISE REST package to help us towards our goal of creating a cross-browser compatible UI. The ISE REST package is a framework for building secure REST APIs to existing persistent classes and business logic in the InterSystems Iris data platform. And our motivating use case was that we wanted to show different navigation menus to the user based on which browser that they were using. Because we needed and wanted to keep the Internet Explorer version of the app available to the users who were doing their day-to-day work the whole time, we wanted to show all the pages if they were using Internet Explorer. However, because not all the pages were vetted or fixed yet when opened in Chrome, we only wanted to show the pages that we had fixed and deemed cross-browser compatible. And this, like the ISE REST package allowed us to do this. We were able to have our menu class extend the ISE REST framework, then implement the get collection method, which is part of like one of the methods you have to implement for the package for classes that implement that framework, and then return the appropriate HTML menu file to use based on the user session data, which because the new UI shares an existing CSP session mechanism with the old UI, we were able to check which browser the user was in to select the proper file with the proper like navigation menu options to show. Okay, so thank you for bearing with us for this presentation. We know that it might not be, and probably is not the most exciting thing to learn about, but it is very important, especially because Internet Explorer is officially retired, and there are better and more modern browser options available that we want to make available to our users. So just to go over some key takeaways that we hope you'll take away from this presentation. A preferred method that we found for our app that we wanted to keep available to users is to do an incremental page rewrite instead of a rip and replace, so that we'd release pages one at a time as they became cross-browser compatible, and that we'd only display functional pages to users. This helps us keep the old UI working and available so we can avoid disrupting the regular workflow of our key stakeholders and users. And we also just want to re-highlight the importance of regularly reviewing this priority list of pages with key stakeholders, as we know this might change, and we just want to keep an open communication with them so that we can provide them like the use cases that are most important to them. And lastly, the gotchas that we went over with CSS syntax and object differences between browsers, we hope that you'll take that away as like more of a cheat sheet for your own use cases if you guys are looking to upgrade your legacy apps, and hopefully find a quicker solution to avoid the pitfalls that we fell into. So thank you. Cool.
But yeah, we have a bit of time for questions if anyone has a question. Yeah.
Can you go back to your second to last slide on the IC REST?
Yes.
So when you move to that IC REST model of framework, do you still use like server-side CSP methods, or you totally get away from any CSP type embedded stuff in your web pages?
We still use CSP.
You still, so is there sometimes you want to use it, sometimes you just want to go through a REST service, or what's the?
Yeah, I think like that would be it. We just want to like open up the option to use this framework so that we can use the REST service to get the right like file to use.
Do you guys get a lot of pushback on separation of models, right? Keep all your application logic in the front end and nothing in the middle, and then the database, and not have it like intertwined with CSP server-side methods, or is that the type of architecture you're moving toward, or?
We're trying to move towards, I guess, a more unified, right? Because it's like, right, half of it's in CSP, right? Half it's in XML, XSL. So that's not quite our priority at the moment, but it is something we are thinking about as we move forward. Like, how do we unify this and kind of keep everything a little more separate? But it's not quite on the forefront of our minds at the moment.
And you also mentioned Zen. So is Zen kind of it's going to go away? Is that right? What you guys say?
Yeah, I believe.
So don't make any new Zen stuff. Start moving away from that other capabilities. Okay. But,
Right.
But CSP is not going away as far as you know.
As far as I know. Yep.
So I get the part that you make all the pages compatible with a different browser. But we found that in Chrome, they don't refresh the page memory when you load a page, so you're getting lower values. And in a real-time application, that just doesn't fly. So did you come across that when you did this development? Or did you test it so that it actually worked with an active application? Web page application that goes page to page?
We didn't encounter, I don't think we've encountered any real problems with that.
Yeah.
One thing about the application is that it's kind of a low volume application. And that,
If you Google Chrome on the internet about flushing the memory of a page, because that's how they get their performance, it doesn't flush the last values. But when you're actually, as an example, you call it patient record out. You have previous patients, you're probably getting the last patient record. So it's not clear in the page of previous values because that's how they get their speed. So I don't know if you encountered that. So it's one thing to build out the pages so that they all flow nicely and you've got alignment and everything else. But when you actually test it, it doesn't necessarily work.
Yep.
So we came across that when we were testing various browsers.
that is interesting. Yeah, I can't say we've run into that, but maybe we should look a little further into it. Thank you.
Did you guys like avoid flushing the memory on like the initial page load, like as a trade-off for speed?
I'm sorry, I didn't hear you.
Or like, would a potential workaround be like when a page is first like reloaded, that like you'd flush the previous memory, like manually, or?
Chrome doesn't allow you to do that.
Gotcha. Yeah, unfortunately, we did not encounter that with our like own upgrade.
Did you land when you built the app? Did you land on a specific recommendation for a browser, the one that worked best?
Yeah, we decided that Chrome worked best. One, it's available like across Windows and Macs. I think Edge also has the same like uses the same like rendering like technology as Chrome. So usually like what would appear if it works in Chrome, it works in Edge. But we currently focus a lot on Chrome because I guess we keep Edge as a reloaded Internet Explorer option for users. So just to like be more like clear about which like browser to use to access the new UI, we recommend Chrome. And then also we found that like we mentioned before, border box, that's like that styling rule doesn't work in Firefox, and that is like a specific Firefox bug that like until they fixed, we can't really do anything about. So that was messing up the rendering of some of the reports that were some of the reports and files that we were like that were important for our app. So we recommend users not to use that. Firefox.
We use it exclusively.
Gotcha.
So, it really depends. What I call it is the browser wars.
Yep.
Edge is in competition with Chrome, Chrome in competition with Firefox, and they all get their way.
Right. Firefox is, the most restrictive generally, and sometimes it's hard to finagle with it to make it, do what you want. Yeah, cool.
Did you guys, by chance, run into any pixel sizing differences between the browsers, depending on pixel spaces between some pixels? Because I found when aligning different tables that have like two window-based kind of correlating windows of an application, that say in Chrome versus Firefox, after a certain amount of time, it'll misalign based on pixel size. Do you run into any pixel size issues?
Would that be related to like the padding and border rules are inherited?
Maybe
Yeah.
I looked at, when I ran that before, I just noticed that maybe I'm just crazy, but it's like really long page. Eventually they'll misalign based on different pixels.
I know when I've looked into like the CSS rules that are applied to individual elements, sometimes like if certain like rules, like if you set the display to like block or inline block for like tables in Chrome, or like the layout to fixed, it will like just ignore specific styling rules for like children elements of that. Yeah, so like one example is like, I think we noticed that there was a lot of styling rules applied to specific table row elements, but when we had a certain display property set, like it would get, those like styling rules would get ignored in Chrome, so that our workaround was, rather than applying it to like the table row element, we'd apply it to like every table cell element, and that seemed to work. So it could be something like really small, like that's causing those pixel differences. Yeah.
All right. Thank you, everyone.
Thank you.